This is Algebra 2. We are on lesson 2-1. We are talking today about the imaginary unit. So the imaginary unit is I, this lowercase I. So whenever you see I for the rest of the year, you are thinking imaginary. And by the way, before I begin and go too far, imaginary is a horrible, horrible way to describe this. I like thinking about the imaginary unit as the unit of the shadow world, this complex plane. The way that we say imaginary is actually if we go back in the history of why we call it an imaginary number, it's because when we said, oh yeah, you can take square roots of negative numbers, I don't remember who it was, maybe I should look up my history a little bit more exactly, but there's another mathematician who's like, ha, you're making up imaginary numbers, as like a diss on thing, saying that you didn't know what you were talking about, and the name stuck, so we call it imaginary numbers. It's a bad name, but it's the name we use. I, it is equal to. This is the definition. Maybe someone knows this already. Does someone know what I is equal to? No? James? Imaginary? Close. It's actually equal to something mathematical. It is the square root of negative 1. I can now take square roots of negatives. If you pull out your calculator and you type in negative 1 and then you hit the square root button, it will say error. Or it will say domain error, something like that. You can't take square roots of negatives. That's because your calculator exists in the real plane, the real world. It doesn't exist with imaginary numbers. Now I'm telling you, from now on, we're allowed to take the square root of a negative, and I'm going to show you the properties of that. So if I square both sides, if I square the left and I square the right, I'll get I squared. What happens when I square a square root? Quiet raised hand for XP. Only one person knows. 3 people know. Andrea, they cancel out, exactly. So what will you be left with on the right-hand side? Negative 1, there it is. So go ahead and write that down. Let me come over here, Andrea, thank you. All right, so those are my initial definitions, I and I squared. Make sure that those are in your summary. It is a red star. So let's try 2 examples. These are very close to what you'll be seeing on the problem set tonight. So I need to find what the square root of negative 36 is. And I do plus or minus here because eventually we're going to be dealing with plus or minus. This just means both answers, both the positive and the negative answer of the square root of negative 36. So first, what's the square root of 36? By looking up at the chart, you see 36. Shout it out on 1, 2, 3. 6. So if I just had square root of 36, it would be 6. But this thing is equal to plus or minus square root of 36 times the square root of negative 1. Remember your radicals from Algebra 1. You can multiply radicals and you can separate them apart as long as they're still being multiplied. Okay, well, I know what the square root of 36 is. You just told me it's 6. And I know what the square root of negative 1 is. I have defined it formally up here for you. Therefore, this is equal to, I still need my plus or minus. That didn't go anywhere. And you're copying this down. You should be writing with your pencil. This is now equal to plus or minus. Well, square root of 36, again, shout that out. 6. And the square root of negative 1, shout that one out as well. Square root of negative 1 is, square root of negative 1, it's our imaginary unit, which is called I. There it is. So this is a plus or minus 6I. And just to see how things got converted, this 36 turned into our 6, this negative 1 turned into our I. That's how we got 6I. All right. I need someone to help me with problem number 2, example number 2. It's slightly different because I can't do the square root of negative 20 quite yet because square root of 20 isn't a perfect square root, but it does transform into something with an I in it. So what are the factors of 20? What times what is 20? If I made a factor tree of 20, can you guys just shout that one out?
10 times 2.
10 and 2.
5 and 4.
5 and 4 could have also been the factors of 20, and I would agree. And 10, what are the factors of 10? 2 and 5. So when I'm making my factor tree, I could have made it like this. I could have made it as Stego was talking about, like this, where 20 was 4 and 5. And then 4 was 2 and 2. It's the same factor tree, 2, 2, and 5, 2, 2, and 5. That's how you get 20. Notice that one of the factors of 20, this factor in particular, is a perfect square. That means if I square root that 4, it turns into an integer. The integer is 2. So I'm going to rewrite this radical. This is now going to be the square root of, and it doesn't need to be that big, the square root of 4 times the square root of 5 times the square root of -1. I have pulled out the -1, which is really important. You need to do that every single time you're taking the square root of a negative. But I've also taken out a perfect square. Any perfect square that you see in there, you can pull that out. Sometimes you might not have some, sometimes you might. All right, so we're going to go through really rapidly for XP. There's 3 answers for each of these, and then the final answer. So 4 people can get some XP. Square root of 4, quiet raised hand. Easy XP. Eva. 2. Square root of 5 is what? Quiet raised hand. Can it be simplified any further? James says no. So it's just the square root of 5. And what about square root of -1? Quiet raised hand. Stego? That's I. So there's my answer. 2 times the square root of 5i. I'm going to put this I next to the 2. So it's going to look like this. 2i radical 5. 2i square root of 5. And there's a teacher error up there. 70 XP plus an extra credit point. Where is it? James?
Instead of putting the 2i together, would you
No, it's still correct if I put the 2 there and the I over there. It's some other thing. Chris?
Is that plus or minus?
It is the plus or minus. I should have been copying down my plus or minus. So please log it in your extra credit tracker. Plus or minus, and that is 70 XP. Good job, Chris. And I need to box my final answer, of course. All right, those are 2 examples. So this one is kind of fun. By the way, SAT warning. If you are planning on taking the SAT, this will be a question on the SAT. They love these questions. Powers of the imaginary unit. Powers of I. If you have mastered this, you have mastered one of the questions that they'll probably ask you on the SAT.
Just one.
Just one. And that's how it works, right? When I teach you the test, you get 1 or 2 a day. This happens to be one of them. And I know that it's on the SAT because I've taken it quite a few times. Okay, we all know what I to the power of 1 is, right? I to the power of 1 is anything to the power of 1 is that anything. Therefore, I to the power of 1 is I. Easy peasy. We've defined up here what I squared is. I squared is -1. I'm just referring back to my notes. What's I to the power of 3? What I want you to do is think about it for about 10 seconds. I to the power of 3, how could I find that? So you're thinking right now, what is I to the power of 3 and how can I find that? And that's 10 seconds. Now I want you to talk in your group. What is I to the power of 3 and how can I find that? Go. All right, now I want to see a quiet raised hand if you want to share what your group came up with. I heard 2 people say it correctly, so I know the answer is out there.
Oh.
Is there a quiet raised hand right there?
No.
No? Do you want to have a quiet raised hand over here?
No.
All right, James, I see a quiet raised hand. Go for it.
regular 1?
Regular 1. How'd you get that?
Because if it's squared by each other, then it would turn into a positive because negative times a negative will be a positive.
I agree with you that a negative times a negative is a positive, but the problem here is I have a positive and a negative here.
Yeah, but that was already negative.
Was it already negative? Here. So that's a good idea, but not quite. You still get your XP. Is there someone else that wants to try this before I give away the hint? Hint, hint, hint. Here's the hint. I to the power of 3 is the same thing as I squared times I to the power of 1. This is your rules of exponents. I add the exponents when I multiply same bases. Well, I know what I squared is. I know what I to the 1 is. Now, do you know the answer? Again, talk with your groups. You have 10 seconds to talk with your groups. All right, quiet raised hand. Who wants to share? Fiona. So this is equal to -1i, like that? Yeah, that's correct. Even more accurately, I think we can just say it's -i. Because -1 of anything is just negative of that anything. -i. So thank you, Fiona. All right, and then of course, I'm gonna be asking all these other questions. Hopefully you're starting to find the pattern because there are 5 more questions, 5 more chances to get XP. I to the power of 4. First of all, how could I find it? How could I find it using the same method of breaking it into smaller powers? Then, once you know how to do that, what is it? What is I to the power of 4? Think about it by yourself. Now talk with people around you. Make sure your whole group understands. Make sure they understand why that's the answer. There's an I in there. All right, I need a quiet raised hand. There's only one person that was able to get it. 2 people that were able to get it. Steph? 1. How'd you get 1?
Because if you multiply I squared and I squared, you get -1 times -1.
Say it louder and again.
So if you multiply I squared with I squared, you get -1 times -1, and they cancel out and go to
I can't say it any better than that. That's the answer. Yeah, thank you, Steph. All right. By the way, if you want to take a quick peek of what's to come, I'm going to be asking you on the backside, what is I to the power of 113? We better be finding some patterns because I don't have to do this pattern 112 times after the first time. We better find a pattern. All right. Let's try I to the power of 5. What 2 or 3 things can multiply together to get to I to the power of 5? Be thinking about that on your own. You have a question? Okay, you have an answer? Okay. We're going to hold off, make sure that everyone has time to think. I to the power of 5. What things can be multiplied together to get I to the power of 5? And then, what is the answer? All right, be talking in your groups. We're back. I to the power of 5. How do I do this? Quiet raised hand. Quiet raised hand. Who knows how to do it? I don't care about the answer. I care about how to do it. Fiona.
you do I to the 4th times I to the 1st, that's 1 times I, which is I.
So that equals 1 times I, which is equal to I. Yeah, there it is. Gio, you had another way to do it. Can you tell us your way?
It's the same way, but instead of using I to the first power and I to the 4th power, I use I to the 2nd power and I to the 3rd power.
And I to the second was,
I.
hold on, I to the second power was
-1.
-1, and I to the third power was
-I.
-I. And then negative times a negative was what?
Cancels out, and it's I.
And it's just I. Yeah, there's another way to get it. There are multiple ways to get these. All of them are correct. All right. I to the power of 6. Now we're starting to go faster because we're seeing these patterns. I to the power of 6. You have 10 seconds to think about it by yourself, not with your group this time. I to the power of 6. What am I going to do? And then after doing that, what is the answer? Go ahead and write it down. It's okay. You have pencils. If you're making a mistake, you can cross it out or erase it. I to the power of 6. How do I do it? Quiet raised hand if you know how to do it and can explain it.
Wait, so it's I -1 I at 1?
Stego, go for it.
Got to say.
I with the power of 4 times I to the power of 2, and that just equals 1 times -1, and then that's just -1.
There it is. It is -1. Yeah, good job. Golf clap, golf clap. Another way that I saw people working was I to the power of 3 times I to the power of 3. That way is slightly harder of getting the answer, but you can still get it that way. So what you'll have is a negative I times a negative I if you do I to the power of 3 times I to the power of 3. That is a positive I squared And we know a positive I squared from our definition here, that is also equal to -1. So you can do it that way. All right. Notice the pattern. I to the power of 1 is I to the power of 5 is I to the power of 2 is -1, I to the power of 6 is -1. I to the power of 7 is what?
Negative
I. Why?
Just see the power. The pattern is 1, 1, -1, -1.
-1.
I.
The pattern is I, -1, I, and then 1.
Okay, I think that all of us can agree that yes, that is the pattern. But I also want to be able to verify it using math like this. Can someone help me verify it with math like that? Stego, you still get your XP. But I want someone to verify this one for me. Why is it -I? Why is I to the power of 7 -I? Gio, go for it.
So if you do I to the 5th power times I to the 2nd power,
Okay,
it's gonna be
I to the 5th power is right there.
I times -1, and it's gonna become negative.
There it is. There's the justification. Thank you, Gio. All right. And last but not least, I to the power of 8. What is the answer and why? You have to explain both. I to the power of 8.
Okay, we can do this again, guys. Remember, if you do this twice, you become that. It's the answer.
Fiona, go for it.
Wait, hold on.
That's the same thing as 1 times 1 or 1 squared, which is equal to 1. There it is. Which happened to be 1 over there. I can make this slightly bigger. All right. So hopefully we found enough of a pattern that we can apply it to example 3. Mr. Sindel is going to do example 3, and then I'm going to let you guys do the harder example 4 on the back. Yep, that's how it works. All right. Example 3. Which of the following is equivalent to the complex number I to the power of 13? How lovely. All 4 possible choices, A, B, C, and D, and it matches with our pattern backwards and messed up and everything. So I know it's one of those 4, obviously. But how do I tell which one it is? The easiest one for Mr. Sindel to use is I to the power of 4. I can multiply by an infinite number of I to the power of 4s, and I know I'm going to get 1. I can multiply by 1 endlessly. It's easy to do. Ready? 100 times 1, 100. 122 times 1, 122. Multiplying by 1 is nice. I'm going to try to look for multiplying by as many I to the powers of 4 as I would like. So, how many of those I to the power of 4s does Mr. Sindel see? Well, I see I to the power of 4, there's 1, times I to the power of 4, that's 8. I to the power of 4, I'm at 12. Oh, I can't go any farther, times I. I know that this one, I to the power of 4, that is 1. I know this one is 1. I know this one is 1, and I know I to the power of 1 happens to be I. My correct answer is B. That process is important. There's a shortcut that I'm about to show you too if you want to use it. But you need to have a solid grounding on why did Mr. Sindel have a bunch of I to the powers of 4.
Oh my god.
All right. That's some time. I see some people are still working on it. I want to make sure we have enough time to digest that. But I also need to make sure that we get through our lesson. So here, do you have a question? Just stretch. Okay. Here's the shortcut. And this is the shortcut that you might want to use on example 4 because it's such a big number. With really big numbers, shortcuts do help out. I'm looking for the biggest multiple of 4 that goes into 13. The biggest multiple of 4 because, again, I'm looking for nice 1s. I to the power of 4 is 1. That's why I'm looking for multiples of 4. The biggest multiple of 4 that goes into 13 is 12. The remainder is just 1, I to the power of 1. If it was I to the power of 14, the remainder would have been 2, but the highest multiple is still 12. Anything that's a multiple of 4 in the power is still going to be 1. And then I'm left with the remainder. This does assume that you know these key rules. In fact, if I had to, I think I'm going to do this also. These 4 things need to be written down in your summary. I to the power of 1, 2, 3, and 4, all 4 of those things have to be in your summary. Those are super important. So that was a shortcut. Find powers of 4, pull it out, and then whatever the remainder is, I know that by the definition from those first 4. What I'm going to do now is flip over the paper, and I'm going to give you guys example 4, then we're going to pause, see if we're right, then we're going to do example 5, pause, and see if we're right. So, with your group mates, work on example 4. All right, example 4. Someone explain how to do this problem, 50 XP. Who's going to be doing it? Gio, go for it.
So what I did was
Everyone's paying attention.
I divide 112 by 4.
112 is divisible by 4, is that what you mean?
Yeah, so that's 23 times.
So that means I had to multiply I to the power of 4 times I to the power of 4. All of that, if I went out and did all that, that would be 23 of those.
Yeah,
Okay.
and that's going to be I, so I just multiply I to the 23rd power times I to the first power. That's I. Right?
I'm having trouble understanding.
Yeah,
You want to try doing it on the board?
yeah, I was just doing it.
All right.
So that's what I did. 23 times 4 equals 112 I. That's what I got so far. And I just multiply that by I to the first power.
Oh, I see.
Plus 13.
Okay. Yeah, that makes sense. So yeah, you did have 23 of those, and just kind of translating this into what I already have up here. You knew that all those were multiplied by 1, so you just had to multiply by that I to the power of 1 at the very end to get I to the power of 113, and then that's going to be I. So you're looking for the largest multiple. You kept doing 21 times 4, 22 times 4, 23 times 4, and then once you hit 23 times 4, that was really, really close to 113. It was 112. That's where you stopped, and then you just realized you had a remainder of 1. That's what it sounded like. Fiona.
Yeah, sure. Yeah, that's what I did.
Yeah, so and that's
Yeah, it's a difference.
so we need to change that number to 28. Because 25 times 4 is 100, so it should be over 25. That's right. Thank you, Fiona. All right, so Gio, you still had the process roughly correct. And then Fiona, thank you for catching that. All right.
Okay, I got you.
So we ran out of time. We can't do example 5. It's the same process over and over, seeing how many of those multiples of 4 go in there. If you guys have questions about the notes, I can come talk to you individually. Go ahead and write your summary. In your summary, you need to have these 4 basic facts. I to the power of 1, 2, 3, and 4. And maybe something about how you can use I to the power of 4, the fact that that's 1, to help you solve I to large powers. Once you finish your summary, go ahead and check with people around you. Mr. Sindel is going to come by and check your summary too today, so be careful. Make sure you have a nice summary, and then you can begin on the homework assignment.